micros to mainframes. Let's see, Apple DOS 3.1, Atari Basic, digital cameras, a scanner somewhere? Or did I miss scanners? What else? Basic for, oh, that one I know, I have that one installed. Anyway, I'll let you describe your story, not me repeat it.
All right. So, good afternoon, folks. I'd like to start out by pointing out my voice is a little gravelly. I want to tell you it doesn't hurt, okay? So don't worry about me. Now, Americans, usually when they start a speech, they tell a joke. Well, actually, I spent a lot of time in Japan as part of my job. And one of the things I learned is that Japanese usually start a speech by an apology. But since I've been in both places, I would like to, play both worlds here. And I'm going to say that I humbly apologize to you for not starting this speech with a joke. Okay. So, let's see, they said spacebar. So my passion, when I was a young boy, my father told me, do what you love what you do, and you will love your life. Now, when you can make your career, your passion come together, it is a really beautiful thing. And my passion has been computers, but it didn't start out that way. I originally attended Virginia Tech, which has a full-time Corps of Cadets, and I was an Air Force ROTC. And my goal was to become what the Air Force calls scientists in blue. I was majoring in physics. However, I didn't pass the Air Force physical exam. So that was one passion gone away. I needed to find another way. Well, fortunately, in 1966, this magazine came out, and it was all about computers. And just take a look at the index here. Things like computer logic and memory, computers' inputs and outputs, time sharing, use of computer in space. Space was really big, artificial intelligence. And I decided I really wanted to work with computers. And I really would have changed my major, except that Virginia Tech didn't have a major in computer science. Hardly anybody had majors in computer science. So I had to put my passion on a back burner until I could graduate. Now, my first job out of college was at a place called the Applied Physics Laboratory. This is part of Johns Hopkins University in Maryland. And I was interviewing there, and my job was basically going to be what they call a lab rat. You don't have a BS, in physics, what can you do with that? So I was being interviewed and I was being shown around the building. And one of the things they showed was there was a room overlooking computers, a big glass window. There was this room full of computers. One of the computers was this 360 Model 91. And at the time, this was one of the world's fastest computers. Actually, upstairs, they have a control panel for a 360-91. And this is a computer that has 60 nanosecond cycle time, 6 megabytes of memory, and on a 32-bit bus. So it's a really great computer. They only made about 11 of them. And they had other computers, too. They had an IBM 14010 that was connected to a 1302 disk drive, which held about 58.5 million characters. And that was connected in turn to a 7094. So the 1410 was an I/O device for the 7094. The 7094 was a 2 microsecond computer with 32K of memory and 32-bit words. So it was kind of a supercomputer in its own right in the 60s. And they also had a 360 Model 40, which did the same thing with another 7094 instead of the 1410. So I saw that and I said, I want to work with that stuff. And they said, well, you're not being interviewed for that job. However, you can become a computer operator if you like. It doesn't pay as well. And I said, heck yeah, I want to do that. So I got hired as a computer operator. And then as a computer operator, I learned how to operate all those machines. In the downtime between starting a job and ending a job, I had not much to do. So I learned how to program each of those machines. And I wrote a check balancing program and would write games. And at the request of one of the scientists, I ported a 7094 program to the 36091. And after doing all this and learning programs, I wanted to do programming full time. Well, I really couldn't move up that soon at the Applied Physics Laboratory. So I started looking at want ads. And I got hired for a really exciting job.
Space, the final frontier.
So space at that time was really, really big. And what I got hired for was a program called the Manned Orbital Laboratory. This was an Air Force project. They were going to put a space station up and use it as a spy satellite. And they would transport 2 guys up via Gemini capsules, and they'd spend up to 40 days up to them. So my job was to come out to Lockheed in Sunnyvale, California, from Maryland, where I was. So I moved out to California in March 1969. And my job was to create software for the control room, which was to be in the Blue Cube at Sunnyvale. Anybody remember that place? Yeah, it's all torn down now. But so the first job I had was creating a program called ARAND. This was a random number generator, and it was to be used to write random numbers on a disk drive to cover over secret data, or top secret data. And I got done with that pretty quickly. And my next job was to create a skeleton for what they call a page overlay keyboard for the consoles that these guys used. Now, the Air Force looked at this project, and at the time they said, gee, we can put an unmanned satellite that does this job much better, much cheaper. So I was only there a short time when they canceled the project. Now, they didn't fire me. They didn't lay me off like they did so many other people. They wanted me to work on a satellite computer that required being out in the middle of the Pacific in some island for 6 months at a time. I really wasn't interested in doing that. So I looked and found another job at a place called the Service Bureau Company. This was a division of IBM. And what Service Bureau did was they provided computer time sharing. And basically you could have a terminal in your home or your business and do programming in BASIC, Fortran, PL1. And I was hired to work on the operating system. And these are the kind of terminals that you would use. You'd have a teletype, what's called an ASR31, and an IBM 2741, which was really a selectric typewriter. It had that ball in it. And then to communicate, there was a modem. And the modem was in a box, a wooden box. So you dial in your computer and put the phone in the box, close the cover, and it would either work at 10 characters a second, or the 2741 was 13.5 seconds. And I actually had a 2741 in my home because I was testing the system at night. And so I got to play with it. It was like having a personal computer in your home. However, along came this magazine in 1975 introducing the Altair 8080. And it was an interesting computer, sort of. It was about $439 for a kit that really did nothing. I think it had 128 bytes of memory, and you had to enter data in a ones and zeros on the panel. However, it got me started. I really wanted my own computer. So there was this thing called the Homebrew Computer Club. Anybody remember that? Well, actually, this is a picture of the Homebrew Computer Club. And the reason I'm showing you this picture, you can see it upstairs. It's on the wall up there. And in this picture is myself and Kathleen O'Brien, my wife. I'm kind of pointing to us there. If you go upstairs, you can see it. And in April of last year, this museum hosted a reunion of the original Homebrew Computer Club members and the original Apple founders. And this is a picture I took upstairs. The gentleman standing up in this picture here is named Lee Felgenstein. And this is Lee Felgenstein, 2017. So, two guys, generation apart, standing in front of the picture. And this is a picture of the group of people that came to this reunion. Now notice in the front there's Paul Allen and Woz. Now we have two founders of really huge companies. These two guys had never met face to face before this meeting in April of last year. So we have Paul Allen and Woz. Here I have another picture of 5 of the original founders of Apple II. From left to right, we have Daniel Kotke, Chris Espinosa, Randy Wigington, Bill Fernandez, and Woz. And finally, I have a picture here of Woz telling Paul Allen a thing or two, basically telling him how Microsoft helped Apple win the marketplace. It was an interesting conversation. Now, around 1976, on the market came this thing called the Kim-1 microprocessor. Anybody ever heard of that? All right, well, this was just what I was looking for. It was a complete microcomputer. Only cost $245, and it wasn't a kit. It was fully assembled, tested, it was even warranty. And it came with its own keyboard and display, and it had a 2K of operating system memory and all sorts of documentation. I mean, it was just the thing that I wanted. And this is a picture of the Kim-1. Now, you can see over here, there's the connectors that you can connect to power supply and external things and so forth. And a keyboard with a little display. You can hook it up to a tape recorder to record your programs and so forth. So I got myself a Kim-1. Now, anybody ever heard of the S100 bus? You know, the Altair had a 100-pin bus, and all sorts of companies glommed onto that, and it became something of a standard. There was over 150 companies that made products for the S100 bus, and it actually became an IEEE standard. So I wanted to expand my Kim-1. So what I did was synthesize the S100 bus signals using TTL logic off of the 6502. And then I was able to acquire 48K of S100 memory. And basically I had a 48K Kim-1. So now you got a 48 Kim-1, what are you going to do with it? Well, I need to write some software. Since I worked for SBC, I had access to the IBM 360, and at the time 370, assembler language. So I took the macro assembler for a 370 and wrote a 6502 compiler. I used that 6502 compiler to generate 6502 object code, which I would download into a Call 360 user ID. And then I would have my Kim-1 call that user ID and read the object code into the Kim-1, and then I'd write it out onto tape. Doing that, I wrote some utility programs, and then I wrote a native 6502 assembler. So using the 360 macro language, I wrote a 6502 assembler that ran on the 6502. And then I started to write a basic interpreter. Well, something happened at SBC. There was a company called Control Data Corporation, CDC. And IBM came out with they announced a thing called the 360 Model 92. It was a supercomputer, and it was supposed to be faster than the CDC 6600, which CDC just announced. And so a lot of people held off buying 6600s because they wanted the 360 92. Well, IBM couldn't get the 92 to work, so they never came on the market. Well, as you can imagine, CDC did not appreciate IBM coming up with a fan machine that took customers away. So they ended up suing IBM. And IBM ended up settling that suit for something like, I don't know, I think it was $80 million. And they gave SBC to CDC. Now, to me, working at SBC, that would be like if you worked at Apple and you worked, say, in the watch division. And one day you came in and said, hey guys, the watch division, you're now working for Microsoft. You can imagine how those Apple fellows would feel. Well, that's how I felt. And also, I realized that personal computers were going to kill time sharing. There was a limited lifetime for what I was doing. And I really, really did want to work with microcomputers. So I started looking at the want-ads. And I found this place called Shepardson Microsystems, SMI. And this company was run by a real character, a guy named Shep. He was in the paper tape copying business, among other things. Anybody ever heard of the famous Bill Gates letter cascading or telling guys you really shouldn't be copying my Basic because I worked hard and I'm not making money at it? And that Basic was sold on paper tape. Well, guess who did a lot of copying of those paper tapes? Shepardson. They didn't do it themselves, they did it, people would ask him for it. He also did a assembler for the National Semiconductor M16, and he made cross assemblers, and he did a Z80 Basic and worked on something called the Astral 2000. Anybody ever hear of the Astral 2000? I'm not surprised. He also created other products. Well, he ended up with a contract to write a Basic for Apple. And he had a programmer, one programmer, a guy named Bill Wilkinson. Bill Wilkinson was a genius. This guy, as a part of his Air Force career, he would listen to Russian pilots in the sky and translate them so that they would know what's going on. He was also a music maven. I used to play with him. I would bring in a tape recorder and open it up, start playing in the middle of an orchestral piece, and I'd play about 30 seconds. And he would know exactly what piece it was, exactly where it was, what came before it, what came after it. I mean, the guy was just a genius. And he was an outstanding programmer. And one of the things about Bill, I'll mention a little bit later, but he really, really loved to help people. Anybody ever hear of Bill Wilkinson? And here in the audience, we have Bill's wife and his son. Sadly, Bill passed away about a year ago, and we all really miss him. So, I became the second programmer at Shepardson Microsystems. And what we were working on, what I was working on, was what Apple called Apple Basic. Apple was to be the next generation of the Apple II. And it was going to be a machine with cartridges, 8K cartridges, and so I was working on the Basic for it. Now, my development environment was punch cards. I would punch out 6502 assembler code on punch cards, and they would get assembled on Shep's cross assembler. And the output would be paper tape. And I needed to get that paper tape into the Apple II. So Woz created a card, interface card for the Apple to talk to the paper tape reader. So I could read the paper tape into the Apple II and then debug the program. Now I had a 48K Apple II that was given to me by Woz and Jobs for this particular project. So I was working on the project, and Woz came to SMI, and we were working on that paper tape reader. And he was acting kind of depressed. He was telling me he had developed this floppy disk drive. He was really proud of that. But he also was told, hey, you've got to do the software as well as the hardware. And he was told this by his management, which was Steve Jobs, Mike Markline, the CEO, Mike Scott. And he was saying, I know how to do a lot of software, but operating systems, I don't know how to do that. And I've asked a couple of guys in, and they weren't much help. And I said, Woz, I did operating systems for 10 years for IBM. I know exactly what needs to be done. So Shep, Woz, and Jobs agreed that I should write the disk operating system. So I started working on it immediately, and Atari Basic was put on hold. Now, the design of this disk drive was ingenious. This top picture here is what everybody else was using. The bottom picture is what Woz created. And you can see there's only, 8 small-scale integrated circuits on this thing compared to what's up there. And this is actually a schematic hand-drawn by Woz. I kept this as part of the project, showing exactly how this thing is laid out. And the way he was able to make it work was most of what was done in that big card up at top was done in software in the 6502. This is a thing called RightTrack Sector. And this is kind of the heart. It's the thing that writes a sector and reads a sector. And this is a copy of the handwritten RightTrack Sector that was done by Woz and Randy Wigington. You can see it's hand assembled here. And this code was very tight. It was very timing dependent. There was actually a comment partway down the page that said should not cross page boundary. Because when you did a branch on a 6502 that crossed a page boundary, it added 1 cycle. So this code was very, very tight. As a matter of fact, later versions of the Apple II with a faster clock speed, they had to slow the clock speed down to 1 microsecond so that they could do disk I/O. So we had a contract. Now this one page is the contract. It was a contract for $13,000 that spelled everything that was required. And now you can imagine doing a contract today with a company. It would probably be 50 pages long with lawyers' notes and all sorts of things. Things were much simpler back then. And this was signed by Woz and Jobs and Shep. And it was for $13,000 and signed on April 10th. And the delivery was supposed to be May 13th. And as I said, signed by the guys. Now this is a block diagram of the way Apple DOS worked. This lower part here is kind of the heart of Apple DOS. That is and Apple DOS is really a file management system. And so the file management is the heart of it. And there were these things called data control blocks. That's the way you interface to the file manager. And so if you were working in assembly language, you could just fill these data control blocks with commands like open, close, read, write, and the data required. And then the file manager would take it over, massage it, end up calling read write track sector to read and write the data, which went to the disk drive. However, if you were using an Apple II, you were using it through either Integer Basic or AppleSoft Basic. And neither of those two basics had disk commands. So what I had to do was create a command interpreter. I'd sit there and I'd watch every character type it into Integer Basic or AppleSoft, looking at each character and looking for a command like open, close, read, write. If it came in, I would intercept that and then parse it and make the stuff needed to stuff into a data control block. So I basically had to create an interface for Integer Basic and AppleSoft. Now I was working on it, and remember it was, I think the date was supposed to be May 13th with the original deadline. Well, around May 10th, Apple came back and they said, we want more. And one of the things they wanted was to relocate DOS. Now, DOS, Apple came with three varieties, 16K, 32K, and 48K. So the DOS was set up to load into 16K. And Apple wanted it to be such that if you had 32 or 48K, the DOS would figure out how much memory you had and actually relocate the DOS. Well, 6502 is not designed to be relocatable. So it took some tricky coding to actually do that relocation. But I managed it. And they also wanted a boot disk. And that was a disk that you could shove in to the drive, and when it started up, it would boot up. And they were willing to pay another $4,000. That was what, about a third of what the original contract was. And they wanted it by May 26th. So it got done. This is a delivery I made to Woz on May 30th, 1978. And it was delivered on schedule. However, after delivery, they wanted some more changes, and so here they are. And again, this is another $2,000, and the June 23rd was the due date. And so I delivered it and resumed work on the Basic. And at that time, during that era, Shep hired my wife, Kathleen O'Brien, to also work on the project. And then we heard nothing from Apple on the DOS. July, August, September, they never called me, they never said anything. And then in October, Kathy and I were called over to Apple for a meeting. And one of the things they wanted to talk about was a few DOS bugs. They were getting to release DOS bugs. And there were some issues with BASIC that we had with Apple. And so there was a meeting here, and I had a Randy Wigington. Anybody ever heard of Randy? He was, at the time, a 17-year-old kid and a real genius. Today, he made a lot of money. He's one of the founders of a company called Square. Anybody ever heard of Square? So anyway, this is the first page of the notes of that meeting. And we made an arrangement where I would fix some bugs and make a final delivery by October 6th. And the delivery would be a marked up listing. So I wasn't changing any code. I was just changing a listing by writing on it. And I would give them the source on diskette. And so I handed that over to a guy named Dick Houston. I never touched DOS again, never heard from him again. Now, another thing I'd like to point out is that, remember I was talking about how there was this assembly language interface? Well, Apple never published that interface. So if you were a user, the only thing you knew was the interfacing from BASIC, from the keyboard. Well, we had guys writing games and so forth that wanted to do an assembly language interface, but they didn't know how to do it. Well, along came this guy writing a book called Beneath Apple DOS. And Beneath Apple DOS explains how to use DOS from an assembly language. And I had asked Apple for permission to write that same kind of book, and they refused. And theoretically, I'm told they have refused to tell this guy how to do it. And he claims that he disassembled and reversed engineering the DOS to do this. However, I know he didn't do it because he had to have a listing, because there were data structures in there like VTOC, volume table of contents, IOCB, data control block, that I used in my listing that you couldn't get if you disassembled a listing. So he knew what those data structures were called. Anyway, somebody gave a listing, and I believe I know who gave it to him. And I'm not going to say. So, now, Apple Anti-Basic. When we were at that meeting, there was no specification for this. It was supposed to be a simple basic. It was supposed to fit into an 8K cartridge. Well, Apple hired a guy named Jeff Raskins. Anybody ever hear of Jeff Raskins? He was an interesting guy. Anyway, he was assigned to write the manual. And so as he was writing the manual, he just felt free to write anything he wanted. And he really wanted a very powerful, rich basic. And so he was adding more and more and more to it. And we estimated the size was going to be greater than 32K. That's not what Apple wanted. And we talked to Apple, and actually, he called it not so basic, obviously. Kathy and I called it not so basic. And we realized nobody at Apple was responsible for it. And at the meeting, we told Apple, give us some guidance here, give us some feedback. And they said they'd fix the problem. Well, they hired a guy named John Couch to be software VP at Apple. And Couch's solution was cancel the project. So, and that was actually fortuitous for us, because along came a company called Atari. Atari was working on something called Colleen and Candy. These were the code names for the Atari 400 and 800. And this was early 1979. And they had planned to use Microsoft 6502 Basic. Well, by the summer of 79, their Microsoft 6502 Basic was in 12K. They wanted it to fit into an 8K cartridge, and they were kind of panicking. So they came to Shepherdson and asked for some help. So we made a proposal. We offered to write a custom basic for them, and also they needed the disk file management. We happen to have one in the for an Apple or 6502, just happen to have one. And so we made an agreement with them, and the agreement was signed in October 1979, and the delivery was set for April. It was October 78, sorry. The delivery was set for April 79. So that's how much time we had to do it. And they really wanted to make sure we had it on time. So they put in a clause in the contract. There'd be $1,000 a week penalty if we were late. So we said, okay, you want a penalty? We want a bonus if it's early. So $1,000 a week bonus. And so we agreed to it. And first thing we did, I started transforming Apple Anti-Basic. Remember, we've been working on this for about 3 months. And when Apple canceled the contract, they gave us the rights to do whatever we wanted to with it. So Apple Anti-Basic was transformed into Atari Basic. And all the development work for Atari Basic was done on an Apple II, and also for the file management system. Now, the development team for Atari Basic was myself as the project leader, and we had Bill Wilkinson, who did the floating point routines, and a guy, Kathleen O'Brien, my wife, who did the decimal arithmetic, and a guy named Paul Krasno, who implemented the transcendental functions. So we all buckled down, we worked really hard, working off this Apple Anti-Basic, and some features of the Basic. Atari Basic was tokenized. What that meant was that when you read in the code, or when the program read it in, if you had an if statement, the if would get transformed to a token. If you had a variable name, it would get transformed to a token, and so forth. So your statement became a whole bunch of tokens. And we didn't keep the original text. And what that meant was that, say if you wrote an expression out and you tried to set precedents with parentheses and so forth, when you listed it, those parentheses might not be there because they would list it out in the correct order for precedence. Also, Atari Basic did decimal arithmetic, which was unusual at the time. And decimal arithmetic is really great for commercial applications. And also DOS was well integrated into the BASIC. And also sound, graphics, and panel commands were well integrated. So, the Atari FMS, basically we took the heart out of Apple DOS, the file management system, and then changed the, well, we didn't need that Apple Basic and, command interpreter, and we had to modify it for Atari's 128 byte sectors rather than 256 byte sectors. And rather than read RightTrack sectors, I created this thing for Atari called a CIO. Anybody ever hear of Atari CIO? Central Input and Output. And so basically, first working delivery, December 22nd. So remember the delivery was supposed to be out in April sometime? So December 22nd. And everything was delivered on time for January CES. So Atari could actually demonstrate this at CES. And it was about 12 weeks of development time. And basically, we ended up with a $12,000 bonus. So very clever of us to ask for that. So we delivered it, but it really wasn't finished. We had a few bugs to fix, and we had to review manuals, and I had to modify the FMS for the dual density disk drive. And anyway, this was the way Atari Basic was sold. And I've seen some of these Atari Basic cartridges floating around here today. And then this was the FMS and the way it was delivered. And anybody ever use Atari Assembler Editor? Okay, well, Atari Assembler Editor was written by my wife, Kathleen O'Brien. This picture here is me standing in the hallway of SBC, and this young lady is Kathleen O'Brien. This is before we were romantically involved, so I was standing there flirting with her. The picture on the right is later when I was working at Shepherdson. Notice I have an afro there, and my gorgeous wife. Today, by the way, she's a computer science professor at San Jose State. Now, well, we created this book called Inside Atari DOS. Remember there was the similar kind of thing for Apple DOS? Well, this book was written by Bill Wilkinson and myself, and it was released by Compute Books. And it provided a complete listing of the DOS and detailed explanation of how the DOS worked. And actually, a lot of people ended up buying this book to figure out how to write disk operating systems. And Bill and my wife and myself collaborated on a book called the Atari Basic Source Book. This book contained a complete listing of the Atari Basic and also an explanation of how BASIC worked. And this is a picture of me busily working on it. Notice in the background you can see an Apple II with 2 disk drives. Those 2 disk drives were serial number 2 and 3. Now, an interesting thing happened to those disk drives. Later, there was a company called OSS, Optimized System Software, that was created by Bill Wilkinson and his family. And I gave those disk drives to them to work on them. And those disk drives at some point failed. So Bill sent them back to Atari to be, or Apple, to be fixed. What came back was a different set of disk drives. So disk drive serial 2 and 3, don't know what happened to them. And also, I created a thing called the C compiler for Caremco. And this was developed using Whitesmith C on a PDP-11. And it was a several-person project. I wrote the main compiler, which would generate bytecodes. And then Bill Wilkinson took the bytecodes and created the Z80 codes. There was another guy, Paul Krasno, that worked on it also. Later, Bill created a 68,000 code generator from those same bytecodes. So, now, lost interest in the business. And Bill had bought a good deal of the business from him to create OSS. And Kathleen went back to SBC, and SMI wasn't that fun anymore, really. He wanted me to do some things that I weren't interested in. And remember I was saying, do what you love and love what you do? Well, I wasn't loving it anymore. So Atari made me an offer I couldn't refuse. And I ended up at Atari as a manager of system software. And I worked on a project called the Atari 1200 XL. Anybody ever seen that computer? No. Actually, I thought it was probably the most beautiful computer in the world. For some reason, the Atari community at the time thought it was an Edsel. But there's some interesting stories behind it. I was managing the system software and also part of the design team. Now, this thing had 4 function keys. No computer up to that time had function keys. Marketing also wanted a help key. No computer ever had a help key. And no cartridge or anything ran on the Atari had a help key or knew what to do with the help key. And since I was doing the operating system, we've had to do something if the user pressed the help key. So what I decided to do is you press the help key, it would do a self-test. Now, that self-test, it had screen, memory, sound, and keyboard test. For the screen test, it would just do some color displays on the screen. For the memory, it would go through and do memory test, and it would put up little blocks on the screen for each section of memory it was doing, and saying whether it passed or failed. And then it would do a keyboard test. And the keyboard test basically would show a keyboard, and you would press keys on the keyboard, and the corresponding keys would light up. Now, if you didn't press any keys, it would automatically press keys itself. And so the programmer said, well, what should I have it type? And I said, Mike, have it type your name. So the programmer's name was Michael Kohlberg. So if you had an early Atari and you saw the keyboard, it would type out Michael Kohlberg. Later, Atari found out about it and they changed it to say copyright something or other. And then there was the sound. Now, for the sound, the programmer decided that he wanted to do remember the Close Encounters of the Third Kind movie? There was a 4-note sequence. Anybody remember that 4-note sequence? Well, he wanted to do that 4-note sequence. And so that's what we did. But Atari heard that, and they said, gee, that dates the computer. And I said, what does that mean? Anyway, they wanted something different. So they contracted with a company to write an Atari theme song. Now, an interesting story about that theme song. When they contracted to the company, they didn't get the rights to it. So the company waited until we were shipping these things with the Atari theme song. And they said, by the way, you owe us a royalty on that. I just love marketing. So, I was saying the Atari community thought it was an insult. Now, Atari was in trouble. Do you remember back in the era? It didn't look like it was going to be around a long. And I was offered a job with a company called Fox Video Games. Anybody ever heard of them? I'm not surprised. And again, I was manager of software development. And the idea was that we do game development as an engineering task. Usually games at that time were developed by one guy. He would do game design, do the graphics, do the sound. He'd do it all by himself. What we did was we hired a person to do the design. We had another guy or woman doing the sound, and another person doing the graphics. And we'd do one game for many machines. So like the TI and the Atari and the Commodore and Coleco. And so one game, many machines. And these games were based on Fox, 20th Century Fox properties. Things like Fast Eddie, Porky's, and MASH, and so forth. We were actually doing a MASH where we wanted to have a first-person point of view inside a helicopter. So I took the game designer and myself out and we took helicopter lessons just to figure out what it was like to fly a helicopter. And also at the time, Fox was coming out with a movie called Give My Regard to Broad Street. Anybody ever hear of that movie? It was a Paul McCartney movie. And so we were developing a game for it. And we actually, the game programmer and I went down to the studio in LA to saw kind of a draft of the movie. And they were showing the movie in a little private auditorium. There'd be things with insert scene here being shown up there. And all the executives were there and so forth. And so we got a gist of what the movie was about and went back and designing the game. Now, Paul McCartney wanted to see the design of the game before we did it. So the programmer and I, game designer, were actually set up to fly to London to meet Paul McCartney. We got our passports. They were in the process of making the reservations. Now, Fox Video Games cost Fox $18 million, and we weren't making any money. And it was a loss of money. So right about that time, they said they shut us down. So the whole company was shut down. I didn't get to meet Paul McCartney. And neither did the game designer, who was a fanatic fan of the guy. So what do I do next? I went to a company called Voices. Actually, I created with some friends this company. And our task was something called voicemail, OEM voicemail. So you buy our stuff and attach it to your mail system and do voicemail. And I created a scripting language for voicemail. So you know how when you call in and it says press 1 to do this, press 2 to do this, so forth. Well, you can write a script. And so if you press 1, you go here. If you press 2, you go here, so forth. So they made making applications for this pretty easy. It was called VoiceScript. Well, I really, I don't know why I joined this company, because voicemail didn't excite me. Also, the company was a pretty crappy company, actually. There was a lot of turmoil and infighting, and I wasn't having any fun. Remember, do what you do, enjoy what you do, and you'll enjoy your life. Well, I resigned. And I ended up in a place called Logitech. And I was director of software engineering. And they had some products existing, hand scanners. Anybody remember hand scanners? And lots of pointing devices. And that was basically the stuff I inherited as software director. Well, there was this company called DICAM, and it had a thing called the DICAM Model 1. This was a digital camera, and it had 32 grayscale images, 8-bit grayscale images. And they came in trying to sell us to it, and we actually liked it. I liked it. I said, yeah, Logitech should be really the first company to really bring out a consumer digital camera. So I kind of talked people into buying it. And so we made an offer. We paid them $1 million for it. And my job was to develop the software for it. We had the hardware guys had to make it manufacturable. And our market was to be realtors, insurance people, anybody that needed a fast turnaround on images. Also, there's OEM version for medical use. And now, while this project was going on, the company reorganized. We had been functional units. We had a VP of engineering, we had director of hardware, director of software, marketing, and so forth. We reorganized into business units. Each business unit had its own hardware, software, marketing, and profit and loss responsibility. And so I became the director of camera development and continuing with digital cameras. And I started working on the design of a color version of PhotoMan. And actually, I'm going to skip over this. This is kind of telling you how color cameras were made. And while I was working on Color PhotoMan, 2 guys from Kodak came in. And they had a digital camera prototype. And I was really interested in that. I wanted to acquire it for that to become our Color PhotoMan. And so I was interested. I ended up visiting Kodak in New York and going to Chinon and Kodak Japan. Chinon was the Japanese company that made cameras. And I was really sold on the product. I liked what they did. It had 48 color images, 24-bit. And so I told Kodak, yeah, we want to manufacture it. We want to sell it. So I developed a complete section or specifications with the team. We did an industrial design that looked like this. And but we did this, and I was communicating with Kodak, but they weren't responding. And it turned out that their management, Kodak management, said, you can only sell this to 2 companies. And they had already sold it to Apple and Kodak. So they were trying to sell me, but they couldn't sell it to me. Well, turned out Compaq canceled. So they called us up and said, yeah, you really want to do it? So we contracted them. We began working. And I spent lots of time in Japan. This is a picture of myself and the Kodak design team, Chinon, and Logitech, all going out to my favorite meal, shabu shabu. So, let's see, we want to go this direction. So work was going smoothly. 5 minutes. 5 minutes, okay. So, going through it very quickly, there was a meeting with Kodak where my management called me and said, we're canceling the project. And so I talked to Kodak. Kodak said, oh, wait a minute. And they came back with a proposal. Continue doing the project. You don't owe us any more development money. We want to market the camera ourselves, and we're going to call it the DC-40, and you don't have to pay any development expenses, and we'll pay you royalty. And we want you to continue as the project manager. So we created 2 cameras. Here's the DC-40 and the PhotoMan side by side. And next thing I did at Logitech was create a page scan color. The page scan was a sheet fed scanner, and it ran on USB power alone. So no Walmart, and yeah, it was actually introduced in Windows 98, which had robust power for the USB. And the software was done by a guy called Alan Cooper. Alan Cooper was the father of Visual Basic. And he has a company called CooperCom, which does outstanding user interface design products. He's written this book called Cooper.com. He created this popular, powerful software called Scan Bank. And it really helps sell the product. There was a company called Flashpoint. When Steve Jobs went back to Apple, he got rid of everything in Apple that didn't have anything to do with computers. And so he spun off their camera development group and a company called Flashpoint. Flashpoint's project was digital camera operating systems for OEMs. And they were working with Kodak again, creating a product called the DC-260. And Flashpoint was looking for an engineering VP. The guys on the 260 team were part of the DC-40 team, and so they recommended to Flashpoint to ask me to be their vice president. They did. I became the vice president, and it was a tough job because the code base was awful. They had over something like 30 pages of compiler warnings when they would do a build. It was full of global variables, and that's really terrible. If you make a change to something to add a feature, fix a bug, you probably created 2 or 3 more bugs by just doing that. And so I sent these guys to I sent them to a class to learn how to do better. And but every project had to be custom built rather than OEM. And we couldn't get a second round of funding, and so at that point I retired. And Flashpoint exists today as a holding company. So last thing, anybody use Android here? Well, remember I did Basic for Atari? Well, I've done something called Basic for Android. If you go to Play and you type in Basic, the first thing that comes up is Basic for Android. And I started this as a expression processor application, transformed to Apple, first released in 2010. It's free, and it's marketed as Basic. When I did it, I made new releases every week. I had so many users sending me emails that I created a user forum, and it started in 2011. Today, there's over 2,000 users on the forum, almost 40,000 posts, and the first manual was a README, created a Word document. One of the guys on the forum was a professional writer. He took it over. Today it has 238 pages, and also, once you write a page or a program in Basic, you can make a standalone application on it. And now it's an open source app thing. I put the source on GitHub. All those guys, not all those guys, some of the guys on the forum decided they wanted to work on it. So now they're the ones doing the development. I've kind of backed away from it. It's had over 100,000 downloads, and it's got a 4.5 out of 5 rating. I wish I had charged for it. And this is what it looks like on Google Play. So, today, I'm a docent at the Computer History Museum, and again, I'm doing what I love, loving what I'm doing. So, what's next? You tell me. So, do what you love what you do, and you'll love your life. And this is my email address. If you want to see a copy of these slides, here's where you can find them. And I guess I'm out of time. Thank you.
So I hate rushing people off the stage, but this is living proof that every career, every good career, is bookended by Basic and then Basic. Thanks again, Paul. No, come on back up. That was great. Thank you. Everyone, one more time.